Okay, notes for 7.1, parabolas. So in Chapter 7, we're going to start talking about conic sections. And you can see the 4 conic sections that we're going to talk about in this chapter are here below: the circle, the ellipse, the parabola, and the hyperbola. But today in 7.1, we're going to focus on the parabola. So to analyze and graph parabolas, that's where we're going to head throughout this chapter. That's when the whole chapter is going to be about, and we're going to graph them in more detail than you did in Algebra 2, more than just the vertex, the axis of symmetry. We're going to actually put some more to it than that. So in this first paragraph, it says that conic sections, or conics, are the figures that are formed when a plane intersects something called a double-napped right cone. And basically, that's 2 cones facing in towards each other, right here, opposite each other, extending indefinitely upward and downward. So there are 4 common conic sections that we're going to cover in this chapter. And just like we said, parabolas, ellipses, circles, and hyperbolas. So as you can see, the 4 different conic sections are formed by slicing the double-napped right cone in different ways. And the first one, just completely parallel to the horizontal, would be a circle. Slightly tilted would be an ellipse. A parabola is where you only intersect half of one of them. And the hyperbola is where you intersect both of them, like so. Kind of looks like 2 parabolas facing away from each other. Okay, so today, like I said, our focus is going to be on the parabolas. So we're going to start, though, by looking at the general form of equations for all of the conic sections and terms that are going to relate to them. So the general form of any conic section looks something like this. It is capital A squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And this may be the only time that you see this long and drawn out equation, but it does represent the general form of any conic section that we come across. Okay? Some more terminology. The next one is a locus, L-O-C-U-S. This is the set of all points that fulfill a geometric property. A parabola, specifically today, represents the locus or the set of all points in a plane that are equidistant from a fixed point called the focus. So a parabola is going to have a fixed point, which is actually, this is not on the parabola. It's going to be located inside the parabola on the axis of symmetry. But that is part of what helps form a parabola. And then there is a specific line called the directrix. Okay, and we'll visualize those here in just a minute. So a parabola, we know this, it is symmetric about the perpendicular. We know that a parabola is symmetric, but it is going to be symmetric about the line perpendicular to the directrix through the focus, and this you know as the axis of symmetry. Okay, and the vertex is the intersection of the parabola and the axis of symmetry. So let's take a look at these new vocab words that we have and kind of look at this diagram below. So here in blue, we have the parabola, okay, going to the side, opening to the right, and that's going to be something we'll see more of in this chapter. The vertex, as you already know, is, in this case, the farthest point to the left. Now, the axis of symmetry you are also familiar with. It goes through the vertex, and it is a line of symmetry for the parabola. Now, the 2 new terms are focus and directrix. So again, as it says up there, the 2 points, or there is one point that it is equidistant from, called the focus, and a line called the directrix. So this line, change colors. This line here, running along the outside of the parabola, along the vertex, is called the directrix. And then on the inside of the parabola, also on the axis of symmetry, is the focus. And I always mark the focus with an X because in some of the equations we want to make sure that we know the difference between where the focus is and where the vertex is. So I mark the focus with an X. So the focus is always on the inside of the parabola, and it is on the axis of symmetry. The directrix always runs along the outside of the parabola. So as we look, the definition of a parabola is all of the points on the parabola that are equidistant from a focus, which would be right here, to a perpendicular directrix. So from the focus to the parabola, parabola to the directrix, focus to the parabola, parabola to the directrix, focus to the parabola, parabola. Those would be equidistant, and that is what helps, kind of looks like spider legs, that is what helps to create a parabola, okay? All of those lines that are equidistant from the point, which is the focus, and the directrix line. Okay, so now that we have some of those characteristics that we are going to use here in just a little bit as we do our graphs, we're going to go to this chart on the next page, and we're going to look at some of the meanings and some of the formulas that go with these various terms: focus, directrix, axis of symmetry. So the first that we are going to look at here on the left is parabolas that open up and down. So over here on the left-hand side, we have parabolas that open up and down. So as you see right below, we have one that opens up, like so, and we have one that opens down. And let's look at the difference in what makes them open that way. So for a vertical parabola is what I refer to it as, one that opens up or down, you have this form: y equals a times x minus h all squared plus k. And you probably remember this from Algebra 2. When your equation is set up like this, your vertex is hk. The axis of symmetry is x equals h. Now, for the focus and the directrix, I really never use these formulas, but we can talk about them. The focus is a point, remember, so it has the coordinates h and then k plus or minus p. Now, it's not both. It's going to be one or the other, and you really have to know the location of your vertex and how your parabola opens. So essentially, your y value will either add p or subtract p, and we'll talk about what the p value is here in a minute. The directrix then, in this case, is a line that goes through the y-axis, and the value of that line, wherever it goes to the y-axis, is k plus or minus p. And again, it's not that there's two lines. You have to choose whether it's plus or minus. So the last thing we have is the LR, or the focal chord length. And the only equation that I use, and there's some different ones here that you can see, 4p is equal to the absolute value of 1 over a, or p equals 1 over 4a. The only equation I use is this right here. A is equal to 1 over 4p. So what does all this mean? Okay, so as we look at this, let me see. Okay, as we look at this, these two equations right here on the vertical side, these are equations where y is equal to a times x minus h all squared plus k. In both of these, the vertex is hk. Now in the one on the top, a is greater than 0, or a is positive. So when a is positive, the parabola opens up. And here, where a is less than 0, or a is negative, the parabola reflects or opens down. Okay, and that should be familiar to you. Now, the other thing that you have is the axis of symmetry. With this, we have the axis of symmetry coming right down through the x-axis at 0. So the axis of symmetry is x equals 0, and same down here, axis of symmetry, x equals 0. Okay, so vertex, axis of symmetry, whether they open up or down, that should all be familiar. Now, the focus and the directrix, those are new. So the focus, guys, always lies on the inside of the parabola, but it is on the axis of symmetry. So for example, in the top one, my focus could be right here, on the axis of symmetry, somewhere inside the parabola. Now watch closely. The distance from the vertex to the focus is referred to as p, and it will be the same p that we use over in this formula on the right, a equals 1 over 4p. This represents a distance. It is a distance from the focus to the parabola, the vertex. And then we have what's called a directrix. So a directrix runs along the outside. I'm going to actually draw it here. Runs along the outside of the parabola, never touches it. And the distance from the vertex to the directrix is also p. So p is the distance from the vertex to the focus and the vertex to the directrix. And one thing to remember is that a, which is the value in the equation, is equal to 1 over 4p. Now the other thing about the parabolas that we haven't talked about in algebra in pre-cal that actually you didn't talk about them in algebra 2 unless you were maybe in pre-AP was the LR. And the LR is a focal chord. The reason it's called a focal chord is because it goes through the focus point from side to side of the parabola. And this helps us determine how wide the parabola should be. So if this is the focal chord, also known as the LR is equal to 4 times p. So each half of the LR is 2p. So from the focus point to one side of the parabola is 2p, and the focus point to the other side of the parabola is 2p. Okay, so now we're going to label these other triangles and try to reinforce some of these concepts and the parts of them. So let's look at the one that opens down, the negative. Okay, so HK is my vertex, x equals 0 is my axis of symmetry. My focus is now inside the parabola, which means it's below the vertex. And my directrix is going to run along the outside of my parabola above the vertex. The distance from the vertex to the focus is p, and the distance from the directrix to the vertex is also p. So I also have what's called an LR from side to side of the parabola through the focus. Each half of those is 2p for a total of 4p from side to side, and that helps us determine our length across the parabola, or the width of it. Now, these are equations where it is y equals a times x minus h all squared plus k. Those are your vertical parabolas. Now, if we go over to the other side and we look at, and we look at the ones on their side. These go with the equation x equals a times y minus k squared plus h. So these are a little bit different. Now when the parabola is on its side, it is x equal to something with y being squared. So we still have a vertex of hk on both the top and the bottom. Now my axis of symmetry is actually horizontal. My axis of symmetry would be y equals 0, and the same case in the one opening to the left. Axis of symmetry is y equaling 0. The focus point would be on the inside of the parabola, and the directrix would be on the outside. And again, the distance from the vertex to the focus is p, and the distance from the directrix to the focus is p. The formula that I still would use when I'm working with the formula and the graph together is that a equals 1 over 4p right here. And then, of course, through the focus point to each side of the parabola, this is the LR, and that's 2p and 2p, so the LR is still 4p. And again, that helps me determine the width. On the bottom, your focus is on the inside on the axis of symmetry. Directrix is on the outside over here. The distance between the focus and the vertex is p. The vertex and the directrix is also p. And between the two sides of the parabola through the focus is 2p for a total LR of 4p. Okay, so there are my characteristics for parabolas, and now we're going to go ahead and put this into practice. And again, the ones on the side are where it's an x equals something with y squared. Okay, so example 1, we want to determine characteristics and we want to graph this. So I have x equaling something with y squared. So it's a negative 1/12 y plus 5 all squared. So this is going to open to the side, but because it's negative, it is going to open to the left. And it opens left because it's a being less than 0, being negative. Okay, so as I look at this, the 5 is my k value. They switch places. K is always kind of close to y, and h is always with the x. So k and 2 is h. So my hk, which is still my vertex, is going to be 2 and negative 5. Remember, inside the parentheses is always going to come out looking opposite. So my vertex is 2, negative 5. I'm going to come over and graph that. Over 2, 1, 2, 3, 4, down 5. Now this is going to open to the left, so I could maybe start those coming out from the side. My axis of symmetry is going to be y equals negative 5. It shares that y value with the vertex, and it's going to be symmetric about that. Now, identify the focus. Well, the focus is going to be somewhere on that axis of symmetry to the left of the vertex. I know that I have this formula, a equals 1 over 4p. In my equation, a is negative 1/12. Now again, it's a distance, so I really don't even need to worry about a being negative. It's just 1/12, and that equals 1 over 4p. When I cross multiply, 4p equals 12, and p equals 3. So p is a distance from the vertex to each of the focus and the directrix. So I'm going to go from the vertex, and I'm going to go 1, 2, 3 in, mark it with an X. That focus point is now at negative 1, 5. Then my directrix, it has to be the same distance, and I'm going to go back 3, 1, 2, 3, and here is my directrix, which would run along the outside, and that's x equaling 5 is my directrix. Now, if I want to graph the parabola, I need the distance across through the focus, so the LR, which is 4 times p, I know p is 3, so 4 times 3 is 12. If I cut that in half, that's 6, I'm going to go 6 up from the focus, 1, 2, 3, 4, 5, 6, and 6 down, 1, 2, 3, 4, 5, 6, and this helps me graph the width of my parabola so that I'm more accurate. So I have a vertex of 2, negative 5, an axis of symmetry of y equals negative 5, a focus of negative 1, 5, a directrix of x equals 5, and then I have it graphed correctly. Okay, let's look at the next one. Now with these, they want us to write the following in standard form. Now I'm going to cross that out. Standard form is really, what they're really wanting here is vertex form. Or HK form, okay? So then we're going to identify the vertex, the focus, the axis of symmetry, the directrix, and graph it. So if I want to graph it in vertex form, I see that the x is being squared, so my template at the end should look something like this. Y equals a times x minus some h all squared plus k. So I'm actually going to leave the x minus 4 being squared. I'm not going to mess with that. So I'm going to actually divide by 8. And I don't want to go in and divide the x and the 4 by 8. So what I do is I leave this as 1/8 out front of x minus 4 squared. And then I'm going to subtract 3. So vertex form would be y equals 1/8 times x minus 4 all squared minus 3. And this is my vertex form, or my standard form. So now that they want some characteristics, I know that my vertex is going to be 4, negative 3. This is going to open up because A is positive. It's vertical because it's the x being squared. A is positive, so it opens up. The axis of symmetry, so let's see, 1, 2, 3, 4, 1, 2, 3. It's going to open up. The axis of symmetry is going to be over here at x equals 4. Now, the focus and the directrix. We need to get that p-value. So here's my axis of symmetry. There's my vertex. So my focus, remember, A equals 1 over 4p. So my A value is 1/8. That's the same as 1 over 4p. So we can see that 4p is equal to 8 and p equals 2. So what that means is I'm going to go 2 up inside the parabola. And so I have the focus point of 4, negative 1. And then I'm going to go 2 down, and I have a directrix of y equaling a negative 5. And then my LR is going to help me to graph the correct width of that. So the LR is 4p, which is 4 times 2, which is 8. And so from the focus, I'm going to go 8 to the left and the right. 4 to the left and the right. 1, 2, 3, 4. And 1, 2, 3, 4. And this would be the entire graph of my parabola. Okay, let's look at example B. So with this one, we want to write in vertex form as well. So when we write this in vertex form, I am actually going to move over. I need this form, y equals a times x minus h all squared plus k. So I need to do some completing the square. So I'm not going to touch the left at all. I'm actually going to factor out the negative 1/4. And that at the same time, I'm going to put the plus 6 out here. I'm going to scoot the 6 over and factor out the negative 1/4 so I can complete the square. Now when I factor that out, I am left with x squared minus 12. So now we have y equaling negative 1/4 x squared plus 3x plus 6. So what we want to do is we want to move the 6 off to the side, leave a space. We're going to factor out the negative 1/4 before we do the completing the square. And when we do factor out a negative 1/4, that's actually going to turn the 3 into a negative 12, because dividing by negative 1/4 is the same as multiplying by a negative 4. And then in that space, we want to complete the square. We want to make a perfect squared term, so we're going to take half of negative 12, just like we did with completing the square, and then we square it. So half of negative 12 is negative 6, and squared is 36. And remember, there's something that we have to add out here as well, or subtract. We have to balance out what we just did. Well, what is tricky is when you have a number out in front, like the negative 1/4, the number that we truly added, or the value that we truly put on the right-hand side, is a negative 9. Negative 1/4 times 36 is a negative 9. So to balance that, I'm going to have to add 9 right here. Okay, and then when I rewrite my equation, it's y equals negative 1/4 times x minus 6 all squared plus 15. And now it's much easier to go get those attributes. For my vertex, I'm going to have 6, 15. My axis of symmetry will be x equals 6. And I'm going to need my focus and my directrix. Okay, now because the vertex is at 6, negative 15, and these only go 10 up and 10 down, I'm going to use a scale of 2, which means every line will count as 2. So when I find my focus, or as I grab my vertex or graph that, I'm going to go to over 6, 2, 4, 6, and up 2, 4, 6, 8, 10, 12, 14. 215 is going to be right there. We know that it's going to open down, so I kind of get that started. Now to find the focus and the directrix. I know that A is equal to 1 over 4p. Well, I need my distance of p, so I'm going to take a negative 1/4, or just 1/4, and set that equal to 1 over 4p. And as you can see, p is going to equal 1, which means that my focus point is going to be 1 unit down, and since those are both 2, my focus is now going to be 6, 14. My directrix will be 1 above that vertex, and that will be y equals 16. And the LR, the distance across through the focus, is going to be 4 times p, which is 4 times 1, which is 4. So I'm going to go 2 this way and 2 this way, and I will have that parabola. Okay. All right, so that's graphing the parabolas, writing those equations in standard form, identifying some of the characteristics. Okay, the last 3 on this side, we are going to write the equations of a parabola and graph them given the following characteristics. And the key to this is going to be to really visualize what's going on. So the focus in the first one is 3, -4. So I'm going to graph that. My focus is 1, 2, 3, and 1, 2, 3, 4. Now I'm going to mark that with an X so I know the difference between the focus and the vertex. And my vertex is at 1, -4. So I go over 1 and down -4. So this means I have a parabola on its side that's going to open to the right. So my template should be an x equals equation. X equals a times y minus k all squared plus h. Now remember, my vertex is still hk, so I can plug in the h and the k values. X equals a times y minus a -4 squared plus h, which is 1. The only variable that I need left to find is the a value. So to find the a value, I need to remember this formula, a equals 1 over 4p. Now what I can get from the graph is my distance from the vertex to the focus. P is 2. So a is 1 over 4 times 2, which is 1/8. And because that opens to the right, it's going to be positive. So for my equation, the final answer will be x equals 1/8 times y plus 4 all squared plus 1. And the last thing to do to complete our graph is to get that LR value so we know the proper width. So LR is 4 times the p value of 2, which is 8. So from the focus, I'm going to go up 1, 2, 3, 4. Remember, the focus is the midpoint. And down 1, 2, 3, 4. And then here is my parabola. Okay. And then this would be the equation. All right, let's look at example B. If you want, you can pause the video and try to do this one yourself. Okay, here's what we know. We know the vertex is -2, 4, so I'm going to plot that. There's my vertex. And I know that my directrix is y equals 1, so it's going to go through the y-axis at 1. So this parabola is going to open up. This means I have a y equals a times x minus h all squared plus k. There's my template. My vertex, -2, 4, that's my hk value, so I'm going to plug those in. Y equals a times x minus a -2 all squared plus 4, and that's y equals a times x plus 2 all squared plus 4. So then I need my A value. Remember, A is 1 over 4p. So the distance from my directrix to my vertex is 1, 2, 3. So P is equal to 3. So A is 1 over 4 times 3, which is 1/12. And because it opens up, I don't have to make it negative. So it's 1/12 times x plus 2 all squared plus 4. And to finish graphing, we want to remember that LR is 4 times P, or 3, which is 12. So from the focus, which the focus has to be 3 up, 1, 2, 3, the focus is right here. And so I'm going to go, I want the total distance across from side to side through the focus to be 12, so I'm going to count 6 to the right and 6 to the left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so here, oops, kind of missed that. So there is my parabola. Oops. Didn't really mean to. Ah, goodness. Okay, there we go. All right, and the last but not least, the focus is 2, 1. It opens to the left and it contains the point 2, 5. So let's see what we've got. We've got the focus at 2, 1. I'm going to mark that with an X. And then it says it opens to the left, okay, which means it's going to have a negative A value. If it opens to the left, that also means it's going to be an X equals A times Y minus K all squared plus H. And it contains the point 2, 5. 1, 2, 3, 4, 5. Now you notice if it opens to the left, this is right in line with the focus. So I know that 5 is halfway. I'm going to go 1, 2, 3, 4, 5 down. So these right here are each 2p, and I'm sorry, 1, 2, wait, 2, 1, 2, 3, 4, 5. Oh, and I made that just a little too long. Hold on. Sorry. So 2, 1, 2, 3, 4 right there. So 2p is equal to 4. So p is 2. So A is equal to 1 over 4 times 2, which is 1/8, but if it opens left, that's going to be a negative 1/8. Now we need to find the vertex. So if P is 2, then I'm going to go back to, there's my vertex, 1, 2, 3, 4. So my vertex is at 4, 1. That's my HK value. So Y minus K, which is 1, squared plus 4. And then here is the graph. And this just worked out very nicely because the point that they gave us, 2, 5, was actually right in line with the focus. So I could reverse it or reflect it and get that other point. Okay, and this takes us up through 7, 1.